of our trek through music theory for worship. That's the good news.
The bad news is you won't be able to watch our antics of presenting this material to you much longer.
But you remember, we made the promise that we would tell you everything you needed to know, and we would not tell you anything you didn't need to know in the course of this presentation of music theory for worship. So we're about to tell you something you need to know.
Hanson, chemical analysis.
Is this young man Hanson? No, he's not. Hanson was a man named Howard Hanson. He was a composer in the 20th century, and he's not him. But these are helpful because they measure the amount of dissonance in a vertical sonority. Well, that's helpful for the snooty people who are analyzing 20th century music. But it's also helpful for the worship musician.
Do tell.
Because sometimes you want to fatten a chord, don't you?
Yeah.
So I got some plain chords. I'm looking like I'm doing extensions. I'm dropping the bass a third. I'm, all those ways that we talked about to add fatness to a chord. Well, how much fatness do I have? How do I measure the fatness in that chord? It's important to know.
It is.
This is how phrases go. They go certain amount of fatness, more fatness in the penultimate chord. Remember that word?
That is the second to last chord.
And then when we resolve, less fatness. If we got that wrong, let's say I want to go like this.
5-1. Simple 5-1.
I do the non-fat chord first. I do a fat chord. And so, let us learn to measure the fatness. Fat, with that vaunted PH spelling the young people like so much. What we're going to do is measure every interval within this vertical sonority, or this chord. Measure every interval. We start with the lowest note, and we look at the next note up. If it was a second or a third or whatever, we just mark that, okay? We look at the next note up, the next note, however many notes there are in the chord. Then we go to the second from the bottom, so that we don't skip anything. And we measure all the way to the top. We go to the third to the bottom, we measure. And now we've measured all of those intervals. And when we do that, then every interval could be considered to be a tritone or less, augmented fourth or less, okay? So a fifth is really a fourth, because it's a perfect
and the
consonant.
Sixth, inverted, is really just a third.
Yeah, so everything becomes, so we got to shrink them all. Now, of those different intervals, minor second, minor third, major third, perfect fourth, augmented fourth, which do you think is the most consonant?
Most consonant would have to be the perfect interval, of course.
That's why we call it perfect.
Perfect fourth. Then the next one would be the next one that we find in the overtone series, major third.
Major third, that's there.
Then we've got a minor third. Then
More dissonant.
major second. And minor second. But then the least would have to be the augmented fourth, or tritone. For the perfect fourth, P for perfect.
For the major third, M for major.
For the minor third, N.
Because we've already used M.
Yeah, so...
So we go with N.
N.
Minor third. For the major second, we use S for second, because we've already used the M from major.
For the minor second, we use D for minor second.
Because we've already used so many of those other letters.
Yeah.
And then for the tritone, we use T. Okay, so P, M, N, S, D, T. Just learn them like they were a word.
P, M, N, S, D, T.
And they always go in that order because that's the amount of fatness that each of those intervals have. Now, that was Hanson's system. But because I like to quantify the unquantifiable,
As it were.
I have further decided to put a number to that.
P is worth 1, M 2, N 3, S 4, D 5, and T 6, going in order of dissonance and consonants.
Or a fatness quotient, if you will, PQ.
You just made that up.
PQ, like the young people would say.
Mind your P's and Q's?
Q's, both the P's and the Q's. Your fatness quotient is what we're trying to say. Mind
your
fatness quotient. Young man, mind your fatness quotient.
Which brings us to...
Let's try it.
Let's try this out.
All right, we're going to try a major triad. All right, now take a look there on the screen. We have root to the third.
It's major third.
Major third, so we write down M.
M.
And then we go from the bottom to the top.
But a fifth inverted is a fourth, which means it's really a P.
P. So we have P, M. Always write them in the correct order. P and then M. And then we go to the next note up, to the top note.
With a minor third, N.
N. So this is a major triad is a P, M, N.
That's it.
Okay. Now remember how we assigned values to those. That's a 1, a 2, and a 3.
1 plus 2 is 3 plus 3 is 6, which means we have on our hands a chord worth a value of 6.
Let's try a minor chord.
Let's try a minor chord, though.
Let's see how that comes out, okay? So once again, root to third.
Minor third, N.
N. Root to fifth.
5 inverted is 4, which is a P.
P, N. And then third to fifth.
Major third is an M, which means we have the exact same thing, P, M, N.
Ah,
Value
so maybe
of
you've wondered,
6.
Is a major chord or a minor chord more dissonant? Answer,
They're the same.
they're the same. They both have a major third, they both have a minor third, and they both have a perfect fourth.
At that point, it's your opinion.
Okay, so we just learned a little something there.
Yeah.
All right. Now, what if we made it a 2, no 3? Quartal. Let's measure a quartal and see how that stacks up, as it were. Ah, so we have P2, because
So
two
there's two
P's.
Ps.
P2,
S.
S. Well, we add up those values, and it's 1 plus 1 plus 4 equals
6.
6. So what we just discovered is a major chord, minor chord, and a 2, no 3. They're all equally fat.
They're all the same.
One more. Let's try a sus chord.
P2S.
So a C sus is the same as a C2 no 3 as far as the intervals that make it up. There are 2 perfect intervals, and there's a major second.
All these chords with a value of a 6.
So we could use all of those, and they are equally fat.
Or less fat.
They have a PQ of 6.
Now,
Seventh.
what if we were to get a nested string of sevenths? Major sevenths, minor sevenths.
Yeah, let's try it. Let's try that major
Bring them
seventh
all.
first. And we have a
What do you got?
P2M2ND
With a value of
14.
14.
It's worth 14.
With 14 points.
That's pretty fat. That's a
Not
whole lot
bad.
fatter than 6, isn't it?
Oh,
A whole lot. You
14.
add that extra note, of course. Well, that adds more fatness.
right.
All right. What about that minor 7? Again, we're going to go fast.
Line
Now,
it
here
up.
we go. We put all that together, and it's a P2MN2S.
Which added up is
14.
the same.
Major 7 and minor 7 are the same. Now, so far, our little experiment has not been very helpful.
Because
What
we've
we
got
find
just a
out
bunch
is
of 14s and
they're a bunch of
6s.
6s, they're a bunch of 14s.
But,
Let's make a dominant 7th, right?
oh, okay, all right.
Remember, it has a tritone in it. That's where the tension
Ooh,
comes.
tritone
That
is
really-
worth a lot of points.
Yeah. So
6 to be
let's see
specific.
here. All right, we're gonna just do the dominant 7th. Here we go. We say that's a PMN2ST. You notice how the later letters are showing up? N2, S, and T. Add up the numbers.
Well, they're going to get a higher number, and it is
19.
19.
Say major 7th, minor 7th. Those are both 14s.
14.
Just by changing this one half step right there, I suddenly make that a lot fatter.
Yeah.
So because that chord has a tritone in it, the dominant 7th has a tritone in it, it's very dissonant. Now, how's it going to sound if I resolve from a tritone chord, a dominant 7th, to a plain old triad? According to Hanson, he would say
That's a good resolution
that's a lot of fatness
'Cause you go from
to
a
lot of
19
simplicity.
to a 6.
19 to a 6. Okay. Now, we'll string together a bunch of minor sevens. We'll go 3, 7 to 6, 7 to 2, 7 to 5, 7 to 1, and we'll measure the fatness of each of those. And what we find is we go
14, 14, 14, 19, 6.
aha! The psychology, you might say, of music is conflict and resolution, tension and release. We have a problem and we resolve that problem. You know the principle. It's always darkest just before the dawn.
Or before a really big storm.